Let's take a look at this section of probability, section 11.1, and we're dealing with something called the fundamental counting principle. So in short, it's called FCP. And let me tell you, when we use that, it's used when you have a task with several parts. And I'll show you what I mean in just a second. Now, that's a notation for this FCP. There's another part to the title called permutations, which we will do later. And the notation for permutations is a lowercase n, a letter P, and a letter R. And the P is capitalized, so it's called NPR. Now, let's see how we apply the fundamental counting principle. Let's look at the first example that we have, and we'll do it just by thinking about it. In this problem, we are told in problem A, how many different rings can you create if you have to choose one metal from two choices, gold and silver. Let's say G is for gold and S is for silver, and one stone from the following choices, and we have emerald, E, diamond D, and ruby R. So we want to know how many rings we could create for that. So if you think about it this way, you have a task which is to create a ring, and then part one of that task is to choose the metal, so select the metal, and part two would be to choose the stone to go on it. So we indeed have over here a task with several parts. So check mark on that. So how do we organize, the answer? How do we think about it? We could do it, by doing what's called a tree diagram. And what we do is that we put what's going on for the metal here. So for the metal, we either have what? Either gold or silver, so it's branching out as two possibilities. Now let's just assume that we have a gold for the metal. Then what kind of stone could go with that? Either one of the three choices we had, emerald, diamond, ruby. So that's how this splits up this way. Now what if we had silver for the metal? What if we had silver over here? Then what kind of stone could we put on it? Either one of those three, either emerald, diamond, or ruby. So when you look at that and you think about how many stones, how many rings you either got GE, this is the first ring, or GD, or GR. What are the options? SE, or SD, or SR. So how many choices is that? This is 6 rings. So that's not too bad to do a tree diagram when we have so few options. But if you had, let's say, 2,000 metals and 3 million stones, we're not drawing any trees. We need to come up with 6 rings, knowing that we had 2 choices for the metal, and then we had 3 choices for the stone. So the way you can get the answer is this way. If you put a spot for the first part of the task, which is over here to choose over here one metal from the 2 choices we had. So that's really here I'm going to say that this is the number of choices for the metal. That's one way to look at it. So that's my little spot for that. Now next to that, we're going to put here the number of choices for the second part of the task, which is choosing the stone. So the number of choices for the stone. Now how do we get an answer of 6? Let's see. If we had 2 choices for the metal and we had 3 choices for the stone, how do you go from 2 and 3 to an answer of 6 over here? You would have to multiply those two. So that's what FCP does. FCP is when you have a task with several parts and you put down a spot for each of those parts and you write how many ways you can do each part and you multiply them and you get your answer.